Hello. We're going to talk about lumped filter design using Nuhertz filter solutions in the AWR design environment and with Modelithics in AWR. We'll start with the Filter Solutions Filter Quick panel for very fast, easy design. We'll select elliptic. We'll select Bandpass. And we will fill out our design requirements. 200 megahertz center frequency, 100 megahertz bandwidth, 200 megahertz stop bandwidth. We will compute, and here we have a classic bandpass design and nice computed S parameters over here. The first problem we see is our classic design has 3, 6, 7 inductors. Inductors are expensive, they tend to be lossy, they're not real good performers. The fewer inductors we have, usually the better off we are. In Nuhertz filter solutions, we solve that problem with a zigzag topology. Now we come back to our design and we see 2, 3, 4 inductors, one less than the number of poles. And over here we continue to see the very nice S parameters that are computed from this topology. Now the thing we see about this design is it is all ideal elements. In reality, we will be plugging real elements into this design. So with Nuhertz, we do have the capability of selecting S parameters measured from real elements. We'll pull up the menu, Coilcraft 0805 family, and we will pull up the capacitors, AVX 0805 family. And at this point, I should point out that the pop-up S parameter files menus are fully user customizable with this option selection on this options pop-up page. Now here we see we have files for each part. The files represent S parameter files that have been measured for these specific parts by the manufacturer. And over here we have the computed S parameters of this filter over here, and we can get a much better idea of how this filter will perform when constructed in the laboratory. If we wish to see the S parameters in these files, we can click on an element. This pulls up the change panel. It's a left click. Select File, View Touchstone, and now we can see exactly what is in that element and where the frequencies start and stop. Now, if we have AWR, we can use AWR to increase the design accuracy some more. So I will bring up the AWR export panel. This is in the default state. I'll select S22 in addition. Now, so that you can see the export, I will remove, and I will now export directly to AWR and simulate. And the first thing that we see is the S parameter simulation is a match for the Nuhertz S parameter simulation, which is a good thing. And if we look over here at the schematic, we see the elements, but if we look closely, these elements are loaded with AWR data files. And if we go over here to the AWR data files, we will see that file name right here. And if we click on it, we get the S parameter file that was loaded into Nuhertz. So the first thing we see here is that although the individual elements are loaded with highly accurate measured S parameter files, they are connected with ideal lines. In reality, these lines will be physical lines. They're going to have inductance parasitics, shunt capacitance parasitics, and losses. If our frequencies are high enough and or our accuracy requirements are high enough, this may not be adequate for an accurate simulation. And of course, the best way to do the filter design is with Modelithics. This requires a loading of the Modelithics database, which I just did. Over here we have our export control panel all set up for Modelithics, including simulation and layouts. So let's export to the Modelithics database, parts. And here we see our S-parameter simulation. It does not at this point look unlike the previous S-parameter simulations. However, it is more accurate in that Modelithic accounts for substrate parasitics, pad geometry, and part value variation. As you recall, the optimizations in the previous examples only optimized interconnect geometry. With Modelithics, we have the part values are also optimized using AWR discrete optimizations. They will go to the nearest manufacturer part value, which are recorded in these discrete equations here. We will also be optimizing to the nearest manufacturer's part. Let's begin our optimization. Now let's fast forward a few minutes to the end of the optimization, and you can see that our S-parameter simulation is vastly superior to what we were able to achieve without Modelithics. Over here in our Modelithics layout, we can see the interconnect geometry has been optimized. The cell layouts are still here, but each one of these values has been optimized to the best manufacturer's part value to obtain the best S-parameter response.